All right, let's talk about some mineral deposits. I'll kind of go through this fast. It's just some good things to know as we're ending out the Paleozoic. So from the early, we'll break it up. So the earlier Paleozoic, so we're talking about the Cambrian, Ordovician, Silurian, the first half of the Paleozoic era. Some important minerals that we mine out are sand and gravel. Believe it or not, sand and gravel, that's the most common thing we mine out of the earth. In fact, if you've ever driven over the Agua Fria River coming to or from Estrella Mountain on either Indian School or Camelback Road, there's those mines with, it looks like they're just digging out dirt and stuff. Yeah, they're digging out sand and gravel. Building stones, limestone, granite, those sorts of things. But also limestone used in cement manufacturing. So sand actually has a variety of purposes, including, and I've mentioned this in the past, making glass, because sand is silica, quartz, SiO2, or at least high quartz, high silica based sand, and that's necessary for melting in order to make glass. You can also make molds for casting metallic objects, iron, aluminum, copper. You can make bricks for blast furnaces. Sand can contain heat pretty well. You can also pump sand down into oil and gas wells to fracture layers of rock to help that oil and gas get out of the trapped layer of rock. That's the process called fracking. And I mentioned an example of this was the St. Peter sandstone is a good silica, high silica sand. Also, salt and oil. I know, right? Kind of weird. So evaporates under kind of the Great Lakes area formed. Rock salt, rock gypsum are some common things that we mine out of there. In addition, in the same area, we're also getting, there's also reserves of oil and gas in kind of these old ancient reef carbonate limestone, dolostone rocks. Lead and zinc deposits we're finding in Cambrian aged rocks from in Missouri. Those mines have been largely depleted. Now, a little bit later in the Paleozoic Mississippian age rocks, we're still pulling out lead and zinc in Missouri. So as we get into late Paleozoic mineral resources, some of the things that we're pulling out of those rocks are energy resources, excuse me, metallic and non-metallic mineral deposits. And when I mean energy resources, let me explain. I mean coal, oil, natural gas, those sorts of things. So petroleum, which is oil, and natural gas are usually recovered in large commercial quantities in rocks ranging from the Devonian through the Permian. So speaking of oil and gas, those kind of Great Lakes Basin rocks up into Canada have a fair amount of oil and gas, as well as down in Texas have been prolific producers of petroleum and natural gas. I think nowadays when people think oil, they think Texas and thereabouts. Coal, also an energy resource, a fossil fuel. Much of the coal comes from Pennsylvanian age deposits and large areas in the Appalachian region, as well as the Midwest U.S. are underlain by vast coal deposits. So like West Virginia, Pennsylvania, these areas, due to all those swamps when we talked about cyclothems. So most of the coal that we mine out in the United States is bituminous coal. That's all this purple stuff. And so coal country, traditionally in the United States, when people think coal country and coal miners in the 1800s and the 1900s, they're thinking of what happened in Pennsylvania, Ohio, West Virginia, Kentucky, and Tennessee. These are coal miners and black lung. But we are utilizing coal in other places as well. And then anthracitic coal, it's metamorphosed bituminous coal, higher grade. It's just not a lot of it around. It's kind of rare. only available in a few spaces, and again, that's all due to the Appalachian mobile belt creation, the convergence and usually of Pangea, that high heat and high pressure, folding things up, creating heat and pressure, which created enough heat and pressure to metamorphose bituminous coal in some regions. So focusing on bituminous coal, it's about 80% carbon, and the rest of it is kind of impurities. Remember, it's plant remains that have been buried, and a little bit of heat and pressure and time turned all that plant material into coal. So it is a fossil fuel, but you don't really see any fossils in there, very rarely. Bituminous coal, other than being burnt to generate electricity, is also altered to make something called coke. Not coke you drink, not coke from Cocaine Bear, but coke that's used in steel production. So you actually heat up bituminous coal until you kind of drive out all the impurities, and it's not really coal anymore, it's a little bit altered, and the steel production uses that in the blast furnaces to produce steel, because you're taking those banded iron formation material, like hematite and magnetite, which is iron and oxygen in some various amounts. You take some of that stuff, you mix it with coke, and you mix it actually with limestone as well, because the coke and limestone kind of helps to pull out the impurities, so you can make, so you can get pure iron to make steel. Because coke has the effect of stealing iron from the iron ore out of that banded iron formation, leaving pure iron behind. Because if you have oxygen with iron, it's going to oxidize it. We're going to make rust. You don't want rusty steel. Excuse me. So in any case, just a little side note. So you have coal, and you heat it up to make coke. So you add coke, you add the iron ore, like what we get from the banded iron formations, and you actually add limestone as well. You heat it all up, and you get molten iron, and then you get the slag byproduct, which is actually byproduct of limestone. And then you take that molten iron, and then you add in oxygen and some additional alloy materials to take iron and make it into steel. Fun fact. And then with anthracitic coal, again, it's almost 98% carbon, almost pure carbon, very little impurities. Most of the anthracite we found, again, as I showed you, is in that Appalachian region. It's especially desirable because it kind of burns with it's low smoke, it's higher heat, so you're getting more bang for your buck. It's just rare, so it's more expensive. This is the kind of stuff that they try to claim, it's clean coal, when they try to use that terminology for a little while, which is very misleading. It's clean coal. It doesn't produce as much smoke as bituminous coal. It's true, but it's more carbon, so it actually, when you burn it, you release more carbon dioxide into the atmosphere, making climate change worse. So yeah, there's no smoke, but it releases more carbon dioxide. Smoke is somewhat meaningless in the climate change story. So there's no such thing as clean coal, by the way. But again, it is the least common type of coal. So therefore, most of the coal used in the U.S. is bituminous coal. And then again, limestone. We had a lot of these, transgressive, regressive events that laid down calcium carbonate, whether it was sediment, whether it was in reef production, and all of these things made limestones. So there was vast areas of limestone, kind of North America. It's often used in cement manufacturing. It's a softer sediment, so it's more easier to mix. Again, it's also used in those blast furnaces when steel is produced, because it removes different impurities from the blast furnace when making iron. Specifically, it removes silicon dioxide, sand, quartz. So quartz is such a prevalent mineral. It's in almost everything. Remember, in the banded iron formation, you have the iron part, which is usually, or iron ore part, which is usually hematite or magnetite, and then, which is the black or gray layers. Then you have the red layers, which are chert and jasper, which are forms of silica. So you want to get that crap out of there, and because you just want the iron. So what the limestone does when all this is melted, kind of binds to that silicon dioxide and reacts to create a calcium silicate, also known as slag glass. It's a byproduct of smelting iron. That's the Paleozoic era. You know, when talking about this stuff, it's like, wait, what's going on? Just let it sink in. So the big story in the Paleozoic era, a lot of transgressions and regressions, a lot of sediment being laid down. We get the Appalachian Mountains formed. We're starting to get some mountains forming on what is now the west coast of the United States. And then as at the beginning of the Paleozoic, we kind of had the breakup of Pannotia. That was actually more so in the Precambrian, the Proterozoic eon. So we had the breakup of Pannotia and then the formation of Pangaea. I guess I could have just made a 30-second video and said that instead of the 12 videos that I did make. But, you know, whatever. It's good for the soul. So when we look at next unit will be all the life involved in the Paleozoic, the evolution thereof, from the Cambrian and the Cambrian explosion to the end of the Permian. There's some extinctions in there. A lot of these divisions in geologic time are tied more so to the fossil record and not so much the sequences and mobile belt creations which we discussed. You know what? I tell you what, before we get out of here, let me give you another part of the super secret code. It is the number 11, 11, right? The number 11, 11. So add that on to the code there. So in any case, so Unit 10 we'll talk about strictly the Paleozoic life. It'll be much shorter than all of this. It'll be a little bit more to the point because I don't like biology. That's a personal thing of mine because I'm bad at it. So I'm going to take it out on the biosphere. Sorry, biosphere. Hey, it is what it is. So yeah, so that was the Paleozoic era of the Phanerozoic eon. Until next time, I'll see you around.